Hi everyone, I am Kasim Wali and this is my submission for the Autonomous QA Agent assignment. In this video, I will walk you through my complete implementation, explaining the code and my approach and the entire workflow. The complete source code is available on GitHub and I have also a live version deployed on the Azure. This project is an intelligent QA automation tool that uses RAG Retrieval-Augmented Generation to automatically generate test cases and the Selenium scripts from the project documentation. Let me explain what problem this solves. The problem statement is traditional QA requires manual test case creation and script writing, which is time consuming and error prone. Teams often have documentation, but converting that into executable test is a manual process. And my solution is an AI powered agent that ingest project documentation into multiple formats, build a searchable knowledge base using vector embeddings, uses RAG to generate contextually accurate test cases, automatically converts those test cases into runnable Selenium scripts. And my approach to this problem statement is to build a RAG pipeline. Instead of just using an LLM, I implemented RAG to ensure test cases are grounded in actual documentation. And I have developed a modular architecture like document processing, vector storage, test case generation, and script generation. And I have also Dockerized the deployment with proper error handling and logging. And I have built a clean Streamlit UI that non-technical users can operate. And when it comes to a technical architecture and design, let me walk you through the architecture. The project is organized into clear modules. As you are seeing now, this is backend. This is backend folder, and this is assets folder that is used to upload the documents. And this is front end, and it is this is Docker configuration to build Docker containers. In backend, I have used FastAPI for the REST API. I chose this for its async support and automatic API documentation. In service layer, in the backend, it contains document parser for handling multi-format document ingestion, and vectorstore.py manages ChromaDB vector database, and RAG agent generate test cases using RAG, and script agent converts test cases into Selenium scripts. The data flow for this diagram is, as you can see in the architecture diagram, in the readme.file, user uploads the documents and goes through document parser. Documents are chunked into embeddings and goes through the vector database. Here you can see that. And user query, RAG retrieves the relevant context and LLM generates the test cases. When test cases goes to the agent, it generates scripts, and the script agent generates Selenium Python script. And the technology stack that I have used is ChromaDB for vector database, and sentence transformers for document embeddings, and Groq API, fast LLM inference with Llama 3.1, and I have used Selenium for browser automation, and I have used Docker for its containerization and deployment. Let's dive into the code, starting with main FastAPI application. Here is the main entry point. I have defined RESTful endpoints for ingest, for document upload and processing, and generate test cases for test case generation, and generate script for Selenium script generation, and list test cases to retrieve all generated test cases. This above you are seeing is document parser.py in the background. In the back end, the document processor handles multiple file formats. Let me explain the key logic here. Here, the process document function, it detects the file type based on the extension, extract the text using appropriate parsers like PyPDF2 for PDF, Beautiful Soap for HTML. It chunks the text intelligently. I use a chunk size of 500 characters, 50 character overlap to maintain the context, and it returns the structured chunks ready for embedding. Now I have opened the vector store in the backend. Uh, like uh, uh, vector store is crucial for RAG. Here's how it works. I am using a ChromaDB with the all mini LM L6v2 sentence transformer model. This model creates 384 dimensional embeddings that captures semantic meaning. The key methods in the vector store is add documents, embeds and stores document chunks, query, performs semantic search to retrieve relevant context. The beauty of this approach is that when a user asks about the discount codes, it retrieves all relevant documentation and about the discounts, even if the exact phrase isn't used. And now I have opened the ragagent.py in the backend folder. Now the RAG agent, this is where test cases are generated. Here is my RAG pipeline that is used to retrieve, query the vector store for relevant documentation, and augment, inject the context into the LLM prompt and generate function. Use Groq API to generate structured test cases. In RAG pipeline, there are three major functions, that is retrieve, augment, and generate. Notice my prompt engineering here. I explicitly instruct the LLM to base test cases only on provided documentation, include test cases ID, scenarios, steps, and expected results, cover both positive and negative test cases, format output as a structured JSON. Finally, I have opened scriptagent.py in the backend folder. The script agent converts test cases to Selenium scripts. As you are seeing the screen right now, this is scriptagent.py. This is more complex because I need to generate executable Python code, and my approach is filter UI test cases, automatically exclude the irrelevant test, retrieve HTML context, get the actual HTML structure from the knowledge base, and instruct the LLM to use proper selectors and error handling, add error handling, and include WebDriver manager. Clean up the generated code, ensure it is runnable, and I have also added the environment detection so scripts work both in Docker and locally. This was key. This was a key challenge I solved. You are seeing the main functions that I have written in script agent, extract script and the everything that has been included in the extract script. I have opened the front-end folder. In the front-end folder, I have a file name called Streamlit app.py. The front-end is built with Streamlit for rapid development and clean UI. Let me show you the structure. I have organized it into three tabs. Like as you are seeing, the tab 1 is for knowledge base, and tab 2 is for test cases, and tab 3 is for Selenium scripts. In tab 1, file uploader with multiple format support, and it calls the ingest API endpoint, and it shows success or error feedback. In tab 2, it takes the text as the input for the user queries and displays the generated test cases in the extendable sections, stores test cases into session state for the later use. In tab 3, for the Selenium scripts, drop down populated with UA test cases only, shows generated scripts with syntax highlighting, and download button to save the scripts locally. And as you are seeing, like how I can handle the backend communication, I am using request library with the proper error handling. Notice I check for backend availability and show clear error messages if it's offline. And I also implemented session state management to persist data across the tab switches. This improves the user experience significantly. Let's see the live demo and workflow of this application. I am opening the deployed link. Here you can access the deployed link in the GitHub. The deployed link is opening. Now let's see it in action. I will demonstrate the complete workflow. First, I will upload the support documents. I have three documentation files like API endpoints and product specification.md and UI UX guide. The product specification MD contains discount rules, shipping cost, and payment logic. And for UI UX guide txt dot file contains UI validation rules and styling requirements. And for API endpoints dot JSON file contains API specification. And I currently I am uploading HTML document in the web page. Here you can see it right now. I have uploaded, and the system when I click on the built knowledge base tab, the system is now processing these documents and create embeddings and storing them into the ChromaDB. This may take few seconds. Great, the knowledge base is built. We have now a searchable vector database for our documentation. You can clearly see the success message, like it has processed four documents. Now navigate to the test cases tab. I have taken one of the example queries, to take generate all positive and negative test cases for discount code future, and I have now pasted into the text case area. I have clicked the generate test cases on in the web page. It has generated 15 test cases. As you can see, both positive and negative test cases for the discount code future. You can see it is generate 15 test cases. The process behind this is it searches the vector databases for discount related documentation, retrieved the relevant chunks about say 15, say 20 validation rules, sending the context to the LLM, and generate the structured test cases. And these are the test cases that it has generated. You can see in the screen itself, it has generated both positive and negative test cases. Each test case has clear steps and the expected results, all grounded in our documentation. This is the power of RAG. The LLM isn't hallucinating, it's using our actual product specification file. Now let's navigate to the Selenium scripts tab. I have selected one of the test cases here, and I will click on the generate test Selenium script tab, and it successfully generated the Selenium scripts code. As you can see now, I will download the Selenium scripts code. I have downloaded the Selenium scripts file, and I'm currently opening this the code of the downloaded test case. And if you check the generated Selenium scripts, it has proper imports including WebDriver Manager, environment detection for the Docker versus local, robust element selector using IDs and classes, and finally and try-catch error handling. It has detailed logging and assertions and test report generation. This isn't just a simple script, it is a production quality code that handles edge cases properly. As you are seeing now, I have downloaded the script, and I have downloaded and run it on my local VS Code. You can see the execution now. I have run the script. As you can see, it gives the proper result, and the test cases was successful. You can see the status of the test case and the execution report also. like uh, it opens the Chrome browser, navigates to the checkout page, and it enters the discount code save 15. and clicks apply, verifies the 15% discount is applied or not, and it generates the test report. Now you can see this test cases has also passed. Perfect, these test cases passed successfully.